we need to find the derivative of this given function. The given function is arctangent of square root of 1 plus x over 1 minus x, right? So that's what we have given. The arctangent function is composed with that algebraic function is square root of 1 plus x over 1 minus x, and our goal is to see if we can find y prime, or let's say the derivative of y with respect to x, right? So how can we work on this? So since this arctangent function composed with some other function, and we have the composite function here, so what is the first concept that we need to apply? It looks like, okay, we have the composite function, so we need to use the chain rule, right? So whenever we have the composite function, to find the derivative, we need to use the chain rule. But to apply the chain rule, we need to know what is the derivative of the arctangent. And if you recall, one of the formula that we have is, if you need to find the derivative of, let's say, arctangent or the inverse tangent of x, then the derivative of that with respect to x is 1 over 1 plus x square, right? So this is the formula we have. So why don't we apply that formula and combine with the chain rule to find the derivative of arctangent function composed with that algebraic function. All right, so let's work on it. So we know the derivative of the arctangent of x is 1 over 1 plus x square. How to apply the chain rule? Well, we need to know the derivative of the inverse tangent, which is 1 plus 1 over x square. We compose that function with this function over here. So on that case, we have y prime equal to 1 over 1 plus, and instead of this x, so since we are composing with this given function square root of 1 plus x over 1 minus x, so let's write down square root of 1 plus x over 1 minus x over here, so that we perfectly replace x by that. So that's how we compose, right? So all right, so we had to find the derivative of the arctangent, and then we are applying the chain rule, and then for that we apply this formula for the derivative of the arctangent of x. But remember that on the chain rule we also need to multiply by the derivative of the, now on this case, square root of 1 plus x over 1 minus x, right? So that's how we need to that derivative of that function need to be there to multiply with the 1 over 1 plus square root of 1 plus x over 1 minus x, and then raised to the power 2. Alright, so what is left over here? Now only thing we need to do here is just to find the derivative of this, and then which is actually just the algebraic function, and I hope you know how to find the derivative of that, right? So what do? So that is like there is a radical, we can change that into the exponent form, right? So which is what? We can change the square root of 1 plus x over 1 minus x as 1 plus x over 1 minus x raised to the power 1/2. So we can do that, right? Whenever we are doing it, you can clearly see we have a function raised to the power something. So you can say that is also the chain rule, or the particular case of the chain rule we can apply, which is said to be the generalized power rule, right? So when you apply that, then the derivative of that function, this function over here, look like what? Bring the power down, right? So the exponent is down as a coefficient. Write down the function as it is, so 1 plus x over 1 minus x, right? And everything raised to the power 1 over 2, which is the exponent, minus 1, right? And then again, don't forget to multiply by the derivative of 1 plus x over 1 minus x. So it looks like we need to apply multiple rules here, right? So whatever we have recently done is just the derivative of this. So this is what we have figured out here, the derivative of that. But even we are not completed it, because we need to also figure out this, right? So let's do that. So we will now only focus on finding the derivative of this, so which can be actually done by finding what? Using the quotient rule, right? And we can find the derivative of that. So let's apply the quotient rule there. So when you apply the quotient rule there, what do you get? We need to write down the function of the bottom as it is, multiply by the derivative of the top, and derivative of the 1 plus x is just 1, right? And then minus write down the function of the top as it is, multiply by the derivative of the bottom. So the derivative of the bottom on this case is 1 minus x, whose derivative is -1, right? And then everything underneath that we have is square of the denominator. Whew. Finally we're able to kind of at least figure out the necessary derivatives. So if that is the case, let's accumulate everything over here. So we had to figure out the derivative of this arctangent of that function, and then we apply the chain rule here. So when we are applying the chain rule, we needed to figure out the derivative of this function, so which we have done over here, right? And once but whenever we are trying to figure out now the derivative of this function, then we actually end up with finding the derivative of this expression over here, the derivative of 1 plus x over 1 minus x. We needed to figure that out, which by the quotient rule we have obtained. So the main idea we have already applied here to figure out the derivative. The remaining amount of work is just to try to see if we can simplify this. Okay, so let's try to work on that. Alright, so let's begin from the here on the first step. We are not done yet, right? So here 1 over 1 plus square of the square root of 1 plus x over 1 minus x. You know that square and square root kind of inverse of each other, right? On that case you can say they kind of cancel with each other. On that sense you can say this is just 1 plus x over 1 minus x. So you can write it down that, and then times the derivative of these, which we have figured out over here. Now you can simplify this expression over here at the first term, which is 1 over 1 plus x over 1 minus x, by taking the lowest common denominator, which is here 1 minus x, right? When you do that, you will have 1 over, what will we have here? 1 minus x is the lowest common denominator. Then we have 1 plus x plus 1 plus x, right? So that's how we can simplify the denominator. Alright, and then times, now we have this expression here, which we need to simplify, which is just 1/2, and then 1 plus x over 1 minus x raised to the power 1/2 minus 1 will be -1/2, right? Okay, so after this, I hope we are almost done. The first factor over here, let's say that you have something like 1 over 5 over 4. So how do you write down in the kind of regular fractional form? This is kind of reciprocal of 5 over 4, right? 1 over 5 over 4 means, so we can change it into 4 over 5. That is the reciprocal of 5 over 4. So in the same way, we can actually rewrite the first expression over here into 1 minus x. Underneath that we have, sorry, I had a typo here, because when we take the lowest common denominator we would have 1 minus x, right? And then when we take that as the lowest common denominator, we need to multiply by 1 minus x to that, so this is actually minus. Alright, so we have 1 minus x plus 1 plus x at the bottom, and then on that case you can clearly see that x, negative x and positive x, we can combine and then we get 0. So on that case we have actually 1 over 2 over 1 minus x, and which is somehow, by using this concept, we can write down as 1 minus x over 2, and then times, this would be what, 1/2 1 plus x to the power, let's say -1/2. Everything underneath that we can say 1 minus x to the power -1/2, and then now the last term is if you simplify that, if you simplify the last term over here, which is 1 minus x, and then distribute by the -1 here, then we get +1, right? And then positive x, and everything underneath that we have square of 1 minus x. Now you can again combine this like term over here, positive x, negative x. When we combine we get 0, so we just have 1 plus 1 is 2. Okay, good amount of work, right? So now we are actually almost done. So now this is 1 minus x over 2 times 1 half 1 plus x to the power negative 1 half. Underneath that we have 1 minus x to the power negative 1 half times 2 over 1 minus x square. By the way, if you feel this is too much, the derivative was already done over here, right? I mean, there are no derivative operation to be done after this. What am I trying to do is I'm just trying to simplify and then see if we can write down on the simpler expression. Okay, so that was the extra task we are doing over here. So here is 2, here is 2. We can cancel out the common factor, right? And then when we do that, now you can clearly see the remaining things are what are the numbers. At the top we have, let's say, 1, at the bottom we have 2, and then now just combine the expression. Over here we have 1 plus x to the power negative 1 half, right? And then at the bottom we have so at the top we have 1 minus x times 1 plus x to the power negative 1 half. At the bottom we have 1 minus x to the power negative 1 half times 1 minus x square. If you look into it carefully, this 1 minus x, 1 minus x to the power negative 1 half, 1 minus x square, all of them has the same base. So if you like, you can actually combine those, and which can be done by using the exponent law, right? We can do that. So which will be 1 minus x raised to the power. So because we have negative 1 half over here, so let's write down negative 1 half, and then we have here 2 on the power, but they have the same base, so we can actually combine these with this power over here. On that case we can write down here positive 2, and also there is actually 1 minus x over here raised to the power kind of 1, and then that is at the top, right? So if that is the case, we can write down here negative 1, so that we are kind of combining the powers. So let's simplify the power here. So what do we get here? Negative 1 half plus 2 minus 1. If you simplify this, 2 is the lowest common denominator, so we have negative 1 plus 2 times 2 is 4, and then 2 times negative 1 is negative 2, so we have 4 minus 3 1. So wow, okay, this is just 1 half. That's awesome. So this is then equal to 1 half 1 plus x to the power negative 1 half, underneath that 1 minus x to the power 1 half. You can say this is one of the simplification, or actually you can also convert this into the radical by changing the negative exponent into the positive exponent. This can be written as 1 minus x to the power 1 half times 1 plus x to the power 1 half, right? And then after that, since they have the same, both of them has the same power 1 half, so we can actually combine them over here. 1 minus x times 1 plus x, and everything raised to the power 1 half at the bottom. If that is the case, then this is actually 1 over 2 times, now changing the exponent into the radicals, we can write down the square root sign, and then 1 minus x times 1 plus x. If you do that, this will be just 1 minus x square. So this could be the simplification, but do not panic. Okay, if this is too much of work, you think to do it to find the derivative of the given function, although this is the simplified answer, the main task over here, since our goal is to find the derivative of the function, and then we apply the chain rule here, right? To apply the chain rule, we needed to find the derivative of that, which we have done this, and then over here we still need to find the derivative of that, and which is over here. So if you do not like this simplified form, but you are okay with just with this expression, that would be actually even sufficient. But you know that there are lots of simplification we could do rather than writing down that lengthy expression. I mean, if you just write down 1 over 2 times the square root of 1 minus x square, which is much more clear, right? But it is, I think, up to the project that you are working on. Why do you need this derivative? Depending on that, maybe you need one of these type of simplified expression, or maybe just this is also even sufficient sometime.